Hey everybody, this is Mr. Schultz here with you. We're going to be taking a look at section 4.1.2, how does it grow? So once again, that's section 4.1.2, seeing growth in different representations. So in lesson 411, you looked at 4 different ways, and we actually just condensed it down to one, of representing patterns and began to find connections between them. Throughout this chapter, you will explore connections between and find efficient ways to move from one type of representation to another. Today, you will look for specific connections between geometric patterns and equations. As you work, keep these questions in mind. So that was the intro paragraph, and in this picture that is over here on the right, that's got graph, and it's got 3 arrows that point across the table, pattern, and rule. All these things, the graph, the table, the rule, and the pattern, all these things are interchangeable and are ways to basically represent the same relationship. So that's kind of what we are going to be looking at there. Okay, so we're moving forward to question 4-12, tile pattern 1. Examine the tile pattern shown below on the resource page if you want to use that your teacher gives you, or explore using the student e-tool. You can also use the e-tool. I'm mainly going to be drawing it on screen here. So here are the 3 figures, figure 1, 2, and 3. Let's take a look at what some of the questions are to help us out here. So question A for 412 says, what do you notice? After everyone has had a moment to examine the figures independently, discuss what you see with your team. B says, sketch the next figure in the sequence, which would be figure 4 on your resource page or in the e-tool or on paper. And then you will sketch figure 0, which comes before figure 1. Part C says, how is the tile pattern growing? So basically describe it, use marker or colored pencils. And then part D talks about what does figure 100 look like, looking for that description in words, and how many tiles would be in that. So let's take a look at this first one and kind of go through these questions. So our first thing was to sketch figure 4 and figure 0. So figure 4. So let's start off with figure 4. So you're just looking for how is this thing growing here. So I'd take a second, look at the tile pattern, pause the video, and then I'll come back and show you here in just a second. Okay, so the way that I'm seeing this is in figure 1, I've got the center 4, and going from figure 1 to figure 2 to figure 3, it looks like it's just adding a row here. So so in figure 1, it's a 2 by 2. In figure 3, it's a 2 by 3. In figure 3, it's a 2 by 4. So it just seems to be growing there by 1. So I'm going to make this a 2 high by 5 wide. So I've got 2 there, 3, 4, 5. So it's a 2 by 5. Then the other thing I see is that I see these kind of top and bottom, top and bottom squares that are sticking out and building and seem to match the figure number. So I've got one on each side for figure 1. I've got 2 on each side for figure 2. I've got 3 on each side for figure 3. Drawing that out looks like this. So my figure 4 has that centerpiece that is 2 high by 5 wide. And it's got these kind of arms on each side that extend out 4 each. Now, my second thing is to go and to draw figure 0. So now I just need to work this pattern backwards. So here it looks like the red piece then is just going to stay as a 2 tall, but this time it should just be by 1. And then each of these blue arms, well, it matches the figure number, so I shouldn't actually have any of these blue arms. So I'm actually missing the piece that would be kind of sitting off to the top and the bottom there. But since it's figure 0 and it's not there, I can just erase that, and it should just be just a 2 tall red, which is why I like to start with going to the figure 4, because sometimes going backwards, the figure 0 can look kind of confusing. So how is this growing? I just say it's at hole 2 by 1, and then it grows by 1 each time. That's that kind of center red part. And then, you know, I've got one brick is added to each arm. And that's that kind of blue part. So describe figure 100. What would it look like? Well, the arms, or the kind of blue part, would be 100 long, and then the center portion would be too tall by 101 because remember it is one more than the figure number. So then how many tiles would it have? So this is our kind of next tricky part here. Why don't you take a second and think about that, and I'll bring it back in just a second. So if I think about this, I've got two arms that are 100 long each. Well, that'd be 100 and 100, so that's that blue part. And then I'd have a rectangle that's too high by 101 long. So that would be equal to 202. So I just need to add all those up. I should have 402 pieces in total, or tiles in my final pattern. Let's take a look at the next pattern here. So this pattern starts with problem 4-13. There's actually two patterns here, and we're going to do much the same thing, answering those questions of just kind of drawing the figure 4 and the figure 0, and then describing how it's growing and talking about the 100th figure. So why don't you take a second to look at this, and then we'll go through it. Great chance here to pause the video. All right, so here's our figure, and the way that I'm seeing this is I'm seeing this one center tile in the middle that I've got color-coded in red on figure 1, and then each of these arms are extending in each of the four directions, top, bottom, and left and right, and I've got those color-coded in blue. And it looks like the number of tiles on those arms or those extensions matches the figure number. So figure 1 has 1 extending out from each side. Figure 2 has 2 extending out from each side. Figure 3 has 3 extending out from each side. So figure 4 should have 1, 2, 3, 4. You can see that I've got that drawn there. So I just need to draw this last side. So I'm going to draw this with 1, 2, 3, and 4 bricks extending out because it's supposed to match the figure number. So if I take a look at figure 4 then, well, that centerpiece is just always staying the same. And then my extensions, or my blue part, should be extending out on each side to match the figure number. Well, this is figure 0. So again, it's kind of invisible because there isn't anything there to actually extend. So therefore, we can just leave it like that, and it should just be just a single brick. Again, it kind of highlights why it's important, or why I think it's helpful to look at the fourth figure and then go backwards, because the first one, the figure 0, can sometimes look a little bit weird. So I just added how I would describe this. So I said one single red tile in the middle stays, then add one blue tile to each of the four sides. The blue tiles added match the figure number. So figure 1 has 1 tile on each side, and figure 2 has 2 tiles on each side, and so on and so forth. So describing what figure 100 would look like, well, I described much the same way. So it would be 1 red in the middle, and then I would just say that I would have 100 on each of the 4 blue extensions. So then here, the second part is, how many tiles would it have? Well, I've got the 1 red in the middle, so that should just be 1. So I'm going to do that in red. I've got 1 red in the middle. And then each of the 4 arms, so I would have 100 tiles in the 1 arm because it matches the figure number. And then I've just got 4 of those arms. So in total, when I add all that stuff up, I should have 401 tiles. That's a crazy looking L there. It kind of got mashed into my eye. Tiles. There we go. Okay, let's take a look at the next one. All right, so here's our third figure. Again, why don't you pause the video and see what you come up with here. All right, so taking a look here, here's the thing I saw. So in figure 1, in the middle, we've got just these two tiles in blue that just are next to each other, and those are always there. They always just stay. Nothing is growing, nothing is shrinking. It's staying the same. Then off to the left side of figure 1, I've got 2 tiles that are stacked on top of each other, and those seem to always be growing by 1. So in figure 2, it's 3 tall. In figure 3, it's 4 tall. So it always seems to be 1 taller than the figure number. Then in purple on the right side, I've got 3 high. And then in figure 2, I've got 3 high and 2 wide. And then in figure 3, I've got 3 high and 3 wide. So it seems to be growing out wide each time. And the width of that kind of rectangle that's being formed there follows the figure numbers. So in figure 1, it's 3 high and 1 wide, 1 and 1. In figure 2, it's 3 high and 2 wide, so 2 wide and it's figure 2. And figure 3, it's 3 wide and it's figure 3. So you just keep moving on like that. So in figure 4, then I would have my same 3 high and then 4 wide for the purple rectangle on the right side, and then I have my 2 tiles next to each other in the middle in blue that just stay the same, and then my red tiles off to the left, those are just going to be 1 higher than the figure number. So I'd have 1, 2, 3, 4, 5 there, and those just stack straight up. So taking a look now at figure number 0 then. So figure 0, we've always got these 2 blue that are staying in the middle, so I'm going to start there. And then my red left side, well, that was always 1 more than the figure number. So that's just going to be 1 because it's 1 more than 0. And the purple, well, it matched the figure number. So again, we've got these kind of invisible tiles that are not there because there's nothing there because you're at figure number 0. Again, another great example to show you why I think it's good if you start with figure 4 then go back to figure 0. So next, let's take a look at how it's growing. So my description says 2 tiles stay the same in the middle. The red left side, so left side of the figure, is 1 taller than the figure number. The purple right side is 3 taller than expands based on the figure number. So figure 1 is 1 by 3, figure 2 is 3 by 2, and so on and so forth. So describe figure 100. Well, so figure 100 would be much the same. You would have your 2 blue tiles in the middle. You'd have your 2 blue tiles in the middle. The red ones on the left side, red on the left would be 101 tall because it's 1 more than the figure. And then the purple tiles on the right side would be 3 by 100, making a big, huge rectangle there. And then it says, how many tiles would it have? Well, I'd have my 2 tiles from the blue. I'd have 101 from the red. I'd have 3 by 100 from the purple. So that would be 300 tiles in total. So when I add all that stuff up, I would end up with, whoops, and I noticed that I've got my 2 kind of aligned in a weird spot here. So it'd be something like that. So I'd end up with 403 tiles in total for figure number 100. All right, so moving ahead to question 4-14, it says this, putting it together. Look back at the 3 different tile patterns in problems 412 and 413, and to answer the following cool questions. When you compare these three patterns, what's the same, what is different? Part B says, find an equation or a rule for the number of tiles in each pattern, and then label each pattern on your resource page with its rule. What connections do you see between your equations and the tile pattern? And part D says, imagine the team next to you created a new tile pattern and grows the same way in the ones that you have just worked with, but they refuse to show it to you. What other information would you need to be able to predict the number of tiles in figure 100? Explain your reasoning. Well, let's take a look at this, and specifically we're going to focus on this part B here, finding the equation or rule. We're also going to describe it. So I've got a copy of the 3 tile patterns on the next slide, so we'll take a look at what these patterns look like and look for those connections and write the rule. All right, so here we go. So we're going to take a look at this, and it says our first step is we want to try to write the rule here. So this seems really complex. I got this blue stuff happening, I got the red stuff happening. Let's just take it piece by piece. So looking here, I'm going to have my blue ones on the side, and remember that we just said it is the figure number, and we just have 2 of them. This is just plainly just the figure number times by 2 because I've got 1, 2 sides. 1, 2 sides, 1, 2 sides, and then the number of tiles just is the figure number. So my rule is just going to be the figure number times by 2. So in blue, that would just be 2 times by my figure number, which is x. Then for my red portion, this gets more complex. Before we said it is 2 times by 1 more than the figure number. So I'm multiplying by 1 more than the figure number. Well, if my figure number is changing, we're going to call that x plus 1. But this doesn't quite work out because remember, multiplication is supposed to come first. So what I need to do is I need to put a parentheses around this to make sure that my figure number gets added first before it gets multiplied by the height. And this will allow me to say that my figure number of 0 would be 0 plus 1, and then that's 2 times by 1, so it'd be 2 by 1. If my figure number is 1, well then I'll plug that into my x value here, so 1 plus 1 is 2, which is how wide it is, times by my height, which is 2. My height is always 2, it's just this base that is growing. So we're actually using this kind of a distributive property thing like we showed last time, or like we showed at the end of Unit 3. So this is our rule, but this is not kind of fully simplified here yet. So let's do that distributive property and simplify. So remember, this is 2 groups of x plus 1, meaning that this 2 is applying to both of these things. So I'm going to have a 2x plus 2, and then I've got my 2x from the beginning. So I now can combine 2x and 2x. My rule here will be 4x plus 2. So this is what's telling me my total tiles. This is what's telling me my total tiles. Let's take a look at the next one. Well, the next one, let's start with the red part. Well, that's pretty easy. That's just 1. It is just always 1. And then in the blue parts here, well, it matches the figure number. So there's 1, but there's just 4 of them. Here there's 2, but there's just 4 of them. Here it's 3, but there's just 4 of them. So we're just going to say that it's our figure number times by 4. So 4x. Lots of times when I write rules, I like to put the x value first. So it would be something like that. But either one of those things there I think is great, and it would work out fantastically. Let's take a look at our last one here. So our last one is going to look something like this. Well, again, we've got that blue part. Let's just start with the easy thing. That's just staying put. It's always 2. So that's going to be 2 plus some other stuff. So if we take a look at the purple, well, the purple is just 3 high times by the figure number, 3 high times by the figure number. So that should just be simply 3 times by your x value, because it's 3 high times by the figure number. And then our red gets a little bit weird again, because remember, it's that figure number, but it needs to be 1 bigger than that. So 1 bigger than that, well, we can just write that simply as plus 1. So I'm just going to say x plus 1. If you want to put it in parentheses, you can, but since it's all addition, it doesn't matter if the parentheses are there or not. So now I'm just going to combine my like terms. I've got 3x and x, so I would end up with 4x. I would have positive 2 and positive 1, so this would be positive 3. And now if we start to look and compare these rules, look at this. So this is 4x plus 2, this is 4x plus 1, this is 4x plus 3. They're all growing by 4x or 4 times, but they're just starting from different points. Some start with 3, just like this one. Some start with 1, just like this one. And some start with 2. And that's it there. Okay, that should be everything for today. Your homework is going to be 4-17 to 4-21. Those 5 problems, and that should be it. If you have any questions, feel free to reach out to your teacher. They would love to help out. Have a great rest of your day.